All right, so we're in a new chapter, chapter 13, where we get to use trigonomic functions. And section 13.1 is being able to use trigonometry with right triangles. If you look at the triangle I have here on the screen, it's a right triangle. And the triangle is made up of sides and angles. The right triangle here has a right angle that's denoted right here. And what we have here is we have a specific angle, and we call that theta. And we can use trig functions to help us find certain values in our right triangle. Anything that's if we're using this triangle here to reference our um, our right triangle, we have theta there on the left. If we look to the side that is opposite, that's considered the opposite side. And then we have the side that's right next to angle theta, that is considered the adjacent side. And then we have the angle that is opposite of our 90-degree angle, that is considered our obtuse side. So looking down here, we have 6 different trig functions that help us identify what theta are. So if we have the sine of theta, that is represented by opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Um, Cosecant, secant, and cotangent are inverses of either the sine, cosine, tangent, respectively. So cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over hypotenuse. So looking at some triangles here, we want to evaluate the 6 trig functions of theta. So basically what they want us to find is they want us to find sine of theta, cosine of theta, tangent of theta. Then we got cosecant, theta, secant, and then lastly cotangent. So here they give us 2 measurements. One side is 24, the other side is 7. They don't give us the hypotenuse, but we can find it by using Pythagorean theorem. So saying I can go 7 squared plus 24 squared is going to give me c squared. And that's going to be, what, 49 plus 576, which gives us 625. The square root of 625 happens to be 25. So if I use my definitions that we had above, I can figure out what sine, cosine, tangent, secant, cosecant, and cotangent of theta are. So for the first one, this one's going to be, it is opposite over hypotenuse. And for cosine, it's going to be adjacent over hypotenuse. And tangent, it's going to be opposite over adjacent. And then the ones corresponding are just the reciprocals of each other, so it's going to be 25 over 7, 25 over 24, and 24 over 7. Same thing goes for example B. I'm just going to find sine, cosine, tangent, cosecant, secant, and cotangent. Same thing as above. I'm given one hypotenuse, I'm given one leg. So here I can use like 6 squared plus b squared equals 100. Well, 10 squared, which is 100. So 6 squared is 36, so 100 minus 36 gives me 64. Square root of 64 gives me 8. So I can use that to help me find what those definitions will be. So the sine of theta is opposite over hypotenuse, so it's going to be 8 over 10, but if I reduce that down, it's going to be 4 over 5, Cosine, it's going to be 6 over 10, but I can reduce that to 3 over 5. And then tangent's going to be 4 over 3. And then these are just the reciprocals, so I'm going to write this as 5 over 4, 5 over 3, and then 3 over 4. Okay? Looking at the examples here, these are very common trig ratios that these are for special triangles. They're for the 30-degree, 45-degree, and 60-degree respectively. And each one of these has a very specific value when you punch in the sine of 30 degrees instead of writing theta, or the sine of 45, or the sine of 60. Each of them has a specific um, value that we can give when we punch it into our calculator. So, and it comes from the definitions that we did on the first page. So if we had the sine of 30, it ends up going to be 1/2. If I had 45, it's going to be square root of 2 over 2, 60, square root of 3, square root of 3 over 2, and I'll leave you without the suspense. I'll just give you the rest of them. So then that'll help us identify what values I'm looking for. And so these values come from the unit circle, which you should have a reference of the unit circle from one of the notes that I gave you. And then these values are going to help us solve some problems in a little bit. So if we come down here, I have examples A and B where I have a value of x, I have a degree, and I got one measurement. So from here, it looks like I have 45 degrees, and what they give me is the adjacent, and they also give me the hypotenuse. So if I have the adjacent over hypotenuse, I want to use cosine of 45 degrees, and that's going to equal x over 6. And if we look up to the chart, cosine of 45 degrees is the square root of 2 over 2, so I can replace cosine of 45 degrees with square root of 2 over 2, which then equals x over 6. So I can cross multiply, which gives me 2x equals 6 times the square root of 2, I'm sorry. And then if I were to divide both sides by 2, I would get x equaling 3 times the square root of 2. Let's look over here. So here I have 60 degrees. Here I get the opposite, and then I also have my hypotenuse. So opposite over hypotenuse deals with sine. So I got the sine of 60 degrees equals 10 divided by x. And if we look up here, sine of 60 degrees is the square root of 3 over 2. So it's just a matter of replacing that. So I have square root of 3 over 2 equals 10 over x. So now I got square root of 3x through cross multiplying equals 20. Divide both sides by the square root of 3, so now I got x equals 20 over the square root of 3. Now I can't have a radical in the denominator, so I must rationalize the denominator, so I'm going to multiply both the top and bottom by the square root of 3, which then this gives me 20 times the square root of 3 all over 3. Okay. Last thing we have is talks about angles of sight. Here we got the angle of elevation here, and if we remember from geometry, the angle of depression happens to be that same angle. So when we're dealing with problems with angle of elevation, keep that in mind. So for this particular example, we have a parasailer is attached to a boat with a rope of 350 feet long. The angle of elevation from the boat to the parasailer is 57 degrees. I want to estimate the parasailer's height above the boat. So I can say like this is like a triangle here, where right triangle, and this rope here is the 350 degrees. and or not degrees, feet, I'm sorry. And then this is 57 degrees here. They want us to know what the height is, so this is the height. So what I can do is I can say, okay, I got sine of 57 degrees equals opposite over hypotenuse. So it's going to be what, x over 350. So from here, I can multiply both sides by 350, so I got 350 times it by the sine of 57, it will equal x. And so if I multiply that together, I figure out a value for the sine of 57 multiplied by 350. I'm going to get something roughly 293.5 feet. And that is being able to use trigonometry with right triangles. Hope this helps. Until next time.